Hello everyone, my name is Chenchireddy, working as assistant professor in Untitled Engineering College. Okay. In this video, I will explain. Different types of electrical train topologies. In my previous video, I will explain hybrid electrical drive train topologies. In this video, I will explain electrical train topologies. Okay, the subject is electrical and hybrid vehicles. In the subject in fourth year first semester, BTech Triple E. This is JNTU syllabus RIT regulation. Okay. Today I am discussing topic third chapter, unit 3, electrical drive trains, basic concepts of electrical traction and introduction to various electrical drive train topologies, power flow control in electrical drive train topologies, fuel efficiency analysis. This is third chapter, first part. Third chapter, first part in electrical and hybrid vehicles. Okay, I will discuss. In my previous video, I explained electric and hybrid electrical drive trains, basic concept of hybrid traction, introduction to various hybrid drive train topologies, power flow control in hybrid drive train topologies. Okay, if you want to watch this video, I will provide a link in description. Okay, now I will explain this third chapter's first part in PPT. Okay. Introduction to electrical vehicles. Electrical vehicles mainly used two components. One is electrical motor for traction, electrical traction. Next, second one is energy sources. One is chemical batteries, fuel cell, or ultra capacitors, or flywheels for their corresponding energy sources. These four are energy sources: batteries and fuel cell, ultra capacitors and flywheels. Other sources also have, but in JNT syllabus only used in syllabus batteries and fuel cells, ultra capacitors, and flywheels. Other energy sources are compressed and source system. Some other also available. Okay. Electrical motors for traction applications. Next, the second para. The electrical vehicles have many advantages over the conventional vehicles. Conventional vehicles means internal combustion engine vehicles, ICEVs, internal combustion engine vehicles. Such as the advantage of electrical vehicles, such as absence of emissions. Emissions means pollutions. Next, the electrical vehicles are high efficiency. Next, these vehicles are independence from petroleum. Next, quick and smooth operations. Okay, electrical vehicles advantage. These are options in pollutions and high efficiency and no need petrol. And these electrical vehicles will operate very smooth operations. These are the main advantages. Next, this is general electrical vehicle configuration. This is circuit diagram. In the circuit diagram, have mainly three subsystems. First subsystem is electrical propulsion subsystem. Second subsystem is energy source subsystem. Third subsystem is auxiliary subsystem. These three are three subsystems in general electrical vehicle configuration. Okay, in this first subsystem, I will explain what are the components have, what are the element components mainly. Okay, in the circuit have vehicle controller. This is one. Second one is electronic power converter. This is controller. Second one. Next, electric motor. Next, mechanical transmission and wheels. These are the main components in electric propulsion system. Okay, electrical propulsion system means propulsion means this is moving. Okay, next, here brake and accelerator. This brake and accelerators are vehicle controller input. These two, brake and accelerator, are vehicle controller input. This is total electrical propulsion subsystem. Is total block. Next, second one, energy source subsystem. In energy source subsystem, here EMS and BMS are both are different. EMS is energy management unit. BMS means the battery management unit. Okay, in this subsystem have EMS, energy management system. Next, here energy sources. In this energy sources, okay, battery, ultra capacitors, fuel cells. If you have battery vehicle, we will use battery, ultra capacitors, or fuel cells, or flywheel. Okay, there are different sources. Here only showing energy sources. Next, energy refueling unit. This total subsystem have three components. One is EMS and energy source, and the third one is energy refueling unit. Okay. Next, this is auxiliary subsystem. In auxiliary subsystem have auxiliary power supply. Next, power steering and total climate control unit. Recent all vehicles are power steering units. Okay, using power steering only. This total is auxiliary subsystem in these three subsystems. Now, explain one by one. Here have three links. One is this is the mechanical link. Here mechanical link means two lines. These two lines are mechanical links. One is this for mechanical links. It converts electrical motor to mechanical transmission line. This is next here wheels to mechanical transmission. Mechanical transmission to wheels connected here. This mechanical link only in this total EV configuration only mechanical link used in two places. One is electrical motor to mechanical transmission. Next, mechanical transmission to wheel. Okay, here. Next, electrical link. This thick line arrow is the electrical link. Here, electrical link used electronic power converter to electrical motor. Here, next, energy sources to electronic power converter. This symbol is bidirectional symbol. Bidirectional symbol, it converts electrical power motor connected to electronic power converter and electronic power converter connected to motor. Okay, current flow flows from it electronic power converter to motor and motor to electronic power converter. Okay, in regenerative braking mode, motor it will act as a generator. That time, this generator it sends power to electronic power converter. That's why we are using both directions. Here also electronic power converters two directions. Next, here also energy sources and energy refueling unit two directions. Next, energy sources to auxiliary power converter only here only one direction. Okay. Next, one direction showing. Next, auxiliary power supply to power steering unit also one direction. Next, total climate control also only one direction. Next, here energy refueling unit here also only one direction. Only one direction means current flowing only one direction. Here both direction means directions. Energy sources to refueling unit to energy sources. Next, third one is a control link. Okay, this is not in thick. This control unit it connect vehicle controller to energy management unit. Next, energy management unit to energy refueling unit. Okay. Next, here steering wheel to power steering unit. Okay, this control unit only used in three places. One is vehicle controller to energy management unit. Next, energy management to energy refueling unit. Third one, steering wheel. Okay, three places. Now I will explain one by one why we are using these components. Okay, this vehicle controller it controls power. Okay, vehicle controller input is brake and accelerator. This vehicle controller it controlling electronic power converter. Okay, this electronic power converter it add or remove it transmitting power or not based on this it decides electronic power converter. Okay, this vehicle controller used to the command this electronic power converter. This vehicle controller takes command from brake and accelerator. Okay. Next, this electric motor in normal driving condition, electric motor it converts electrical energy to mechanical energy. This mechanical link connected to this motor output to mechanical transmission. When regenerative braking condition, this motor it will act as a generator. Okay, that time this motor will act as a generator. Generator it converts mechanical energy to electrical energy. That electrical energy it converts power electronic converter. That power electronic converter here energy storage, it stores energy. If you have a battery here, okay, if you have battery, this converter, it sends power to battery. This battery will charging, okay, in regenerative braking. Next here, power management unit. In this power management unit, it controlling total in electrical vehicle power supply. Okay, power supply means this energy management unit, it controlling auxiliary subsystem. At the same time, electrical propulsion subsystem. Okay, when required more power, total vehicle, this energy management unit, it sends power. When have battery as uh, battery SOC, charging percentage is very less. That time, this EMS sends less power to auxiliary subsystem, or less power supply to auxiliary power system. It sends more power to electrical motor. Total commanding is this maintaining EMS. Next, this energy refueling unit, it it charges the battery here. If we using battery, it charges the battery. Okay, total, this is the general electrical vehicle configuration. Next, okay, in electrical vehicles, there are 6 possible configurations. This possible of electrical configuration, there are total 6 possible configuration. Now I will explain one by one configuration. Okay, total A, B, C, D, E, F, total 6 configurations. This is first configuration. In the circuit have M and GB and, okay, here D, F, G, have is names is there. This C is the clutch. Next D is the differential. Next FG is the fixed gearing. Next GB is the gearbox. M is the electrical motor. This M means motor. GB is the gearbox. D is the differential. FG is the fixed gear. C is the clutch. Now I will explain this first configuration. First I will explain one by one. Clutch. Clutch is used to connect or disconnect power of the electric motor from the drive wheels. Okay, this clutch used for connect or disconnect electrical motor from the wheel. Okay, this clutch used for connecting or disconnecting purpose motor to wheel. Okay, that's the purpose of clutch is connecting or disconnecting motor to wheel. Next, the gearbox provides a set of gear ratios to modify the speed range. Okay, next, profile to match the load requirement. Gearbox used for controlling the speed and torque. Okay, gearbox used, that's why. Clutch used for connecting and disconnecting. Next, this differential is a D. In this differential is a mechanical device, okay, which enables the wheels of both sides to the driven at different speeds when the vehicle runs along a curved path. Okay, this differential is connected to wheels. This differential is used for moving the wheels, okay, in different directions, like, okay, if curved path in different normal operating condition and curved path, the differential used. Okay, mainly component clutch and gearbox and differential. This is first configuration. Okay, the same diagram, this one. This is first configuration. Battery electric vehicle configuration with longitudinal front wheel drives. Okay, this is front wheel drives. In this vehicle have 4 wheels. These 2 are front wheels. These 2 are back wheels or rear wheels. Front wheel and back wheels. Okay, this type of vehicle required high speed range motor. Okay, here this M and motor, clutch and gearbox and differential. This type of vehicles used high speed motors. This type of motors, vehicles used for long speed, okay, long distance, uh, for used for long distance. Okay, okay, high speed range motors. This clutch used for clutch and gearbox here used for this controlling this motor speed. Okay, this first configuration, battery electric vehicle configuration with longitudinal front wheel drives. In this vehicle, motor, in this type of vehicle, motor, clutch box, gear, and differential used. Next, second configuration, this is battery electric vehicle configuration with fixed gearing and no clutch. Okay, in this circuit, motor, fixed gear, and differential. In this circuit, clutch and fixed gear removed and replaced. Fixed clutch and gearbox removed and fixed gear. Okay, with the electric motor that has constant power in a long speed range. This type of vehicles used. Next, a fixed gearing can be replaced by multiple gearbox unit and reduce the need of flex. Okay, here fixed gearing, can be replaced by multiple speed gearing and reduce the need of flex. In this circuit, clutch removed, only fixed gearing used. Next one, this configuration not only reduce the size and weight of the mechanical transmission, but also simplifies the drivetrain control. Okay, this type of configuration not only reduces the size, okay, reduces the size as well as weight also reduced, but also simplifies. Okay, simplify the circuit, but also simplifies the train control because gearing shift is not needed. Okay, these are the main benefits: reducing the size, reducing the weight, and circuit is simplified. Next point, battery electric. This is third type of the battery electrical vehicle configuration with transverse front wheel drives. Okay, this is third configuration. In this third configuration, the electric motor, next the fixed gearing and the differential motor, fixed gear and differential is three integrated into a single assembly. Okay, this differential and fixed gear and differential connected single assembly connected to both front wheels. Okay, while both axles point at the both driving wheels. This is third configuration. The whole drivetrain is further simplified and compacted. Okay. This is third configuration, battery electrical vehicle configuration with transverse front wheel drive system. In this drive system, differential and fixed gear and motor integrated with single assembly. Next, fourth one, battery electrical vehicle. This is fourth type of configuration. Battery electrical vehicle configuration with dual motor drive system. In previous three configurations, only this first configuration only one motor. Second configuration also we used only one motor. In third configuration also we used only one motor. First three configurations. This fourth configuration we used two motors and two fixed gears. Okay, two motors and two fixed gears connected to two front wheels. The mechanical difference here in this type of configuration, the mechanical differential is replaced by using two traction motors. Okay, here clutch removed and differential also removed. We connected two motors and two fixed gears, two different two wheels. Okay, mechanical differential is replaced by using two traction motors. Next, each of them drives one side of the wheel. Okay, these two, this fixed gear controlling this wheel, this motor, and this fixed controlling this steering style wheel. Okay, this type of vehicles used in curved path. Okay, different speed when the vehicle is running along the curved path. This type of vehicle is very useful. Okay, example, we need to rotate only one wheel we need to stop. That time this type of wheel is very useful. Okay, battery electrical vehicle configuration with dual motor drive. This is fourth type. Next, fifth type, battery electrical vehicle configuration with in-wheel motor drive. Okay, battery electrical vehicle configuration with in-wheel motor drive. In this type of configuration, motor fixed gear. Fixed gear is inserted inside the wheel. Here also fixed gear inserted inside the wheel. Motor is connected outside the wheel. Here also motor connected outside the wheel. Okay, the traction motor can be placed inside the wheel. Next, this arrangement is so called in-wheel drive. Okay, here fixed gear is not traction motor. Fixed gear inserted inside the wheel. Okay, traction motor can be placed inside the wheel. Next, this arrangement is also called wheel drive system. This is wheel drive. Next, the thin planetary gear set may be used to reduce the motor speed and enhance the motor torque. Okay, in this topology, in this configuration, gearbox, fixed gearbox used for reducing the speed and torque. Okay, next, the thin planetary gear set offers advantages. Okay, this gearbox advantages, planetary gear set offers advantages of high speed reduction ratio as well as the inline arrangement of input and output shaft. Okay, the fixed gear is used for controlling the speed of this vehicle. Okay, this is fifth type configuration. Next, this is the last one. This is battery electrical vehicle configuration with outer rotor motor. Okay, this is last one. This type of in this uh, type of configuration, rotor is the wheel outside. Rotor is the wheel outside. Stator is the inside wheel. Okay, the speed of the electric motor is equivalent to the control of the wheel speed. Okay, in this type of configuration, motor speed is equal to the wheel speed. This type of configuration, this is example ceiling fan. Ceiling fan is a stationary part and outer side is the outer part is the rotating part like this. Rotor is the outside and inside is the stator. This is last one. This is last configuration. Okay, this configurations, this type of configuration, we need to use only low speed electrical motors. Okay, if we use high speed electrical motors, that is very dangerous. Okay, total these are 6 possible configurations. Okay, thank you for watching this video.